Hello everyone. So welcome to this session on data acquisition and learning aspects in AI. So in this session, we will explore how data forms the foundation of AI systems and how machines can learn from the data to make intelligent decisions. Throughout our journey, we will examine core concepts like knowledge discovery, data mining, machine learning, computational learning theory, neural and evolutionary computation, and intelligent agent systems. So, this is what we are going to cover. Okay, right. So, first, let us begin with knowledge discovery and data mining. So, in this, we will see how we can extract useful insights from large data sets. Okay, so it is often abbreviated as KDD, knowledge discovery and data mining. So it is the process of discovering patterns or knowledge that are previously unknown and potentially useful. Okay. So what the definition says, it's extraction of meaningful information that is previously unknown. That's what we discussed. So think about the raw data. So they are just the recorded facts. For example, a list of daily transactions at a store. So when we analyze the data, we can extract the information like what is the purchasing trend, what is the relationship between items, etc. So data mining is essentially the process of finding those meaningful patterns. Okay. So in other words, data is what happened while information tells us why it might have happened or what might happen next. So, with this idea, we will talk about data mining process. The process begins with data cleaning. What is it? When we remove inconsistencies and errors. Okay, there then it is called as data cleaning. Next, we will move to pre-processing, so which involves formatting and organizing the data into usable way. Once the data is ready, so you have cleaned it, you have pre-processed it, then we have to identify the patterns using statistical analysis or machine learning algorithms. Then we understand the applications. Means interpreting what these patterns mean in real world terms. Finally, we generate the target data, the useful insights or modules that guides in taking the decisions. So, to simplify it, clean the data, prepare it, find patterns, understand where it is used, and then make decisions. So, according to Tom Mitchell, a field concerned with algorithms that improve performance with the experience, that is called as the machine learning. Okay. Now, we can just try and differentiate between machine learning and knowledge discovery. Although these two areas are closely connected, they have different focuses. First, we will talk about knowledge discovery. So, first, knowledge discovery is about understanding the knowledge, understanding what is knowledge. So, it is broader and it aims to extract interpretable patterns from data. So that helps human beings understand what is going on exactly. Okay, when we talk about machine learning, on the other hand, is about improving the performance of the agent through the experience. It's more focused towards the concepts on how machines can automatically learn and improve. Okay, so here its main focus is improving the agent's performance. Okay, so as it learns, so it will see how the algorithm learns. So while both dealing with both the knowledge discovery and machine learning, both deal with learning from data. So knowledge discovery mostly emphasizes insight and understanding, whereas machine learning emphasizes optimization and performance. So next we will discuss about the applications of data mining. Data mining plays a central role in business intelligence, enabling data driven decisions in complex environment. So let us take a case study or an example. Bank loan credit risk assessment. So first, when we talk about this problem, so when a customer applies for a loan, a bank considers factors like credit history, payment timelines, security, age, salary, etc. So by analyzing the past customer data, the bank builds predictive one minute the bank builds the predictive information. Okay, so this predictive models then are used to find the likelihood whether the new customer, say for example Pavan, will get the loan or not. So, or you can say Ram. I said Pavan, you can take Ram. Okay. So, what will be the result? Result will be either approved or rejected. So, based on the parameters, whatever has been considered. Parameters are the factors that will be considered. Okay. So, next we will talk about each of the theory. First is the computational learning theory. So, it is uh, called as COLT. So, this field provides formal mathematical models and for studying and analyzing algorithms. It helps in understanding how the algorithm works. So, this field is very important, right? Because it is the one which talks about the efficiency, complexity, prediction, accuracy, and overall feasibility of all the learning algorithms. So it provides a framework to understand what can be learned and how efficiently it can be learned, and what is the limitation that exists. The core goal is to inductively learn from the target function. That is, discover the underlying rule that maps inputs to the outputs. Okay. So, what are the applications here? Applications are the machine learning and AI research. It helps in classifying easy and hard problems, and it helps in guiding design of learning systems, understanding learner environment interactions. Now we will discuss about the two key frameworks in COLT. Okay, first one is probably approximately correct, PAC, examines which hypothesis class can be learned with high probability. The idea is that learning doesn't need to be so perfect, just good enough most of the times. For example, if your email spam filter correctly classifies 95, 98 or 95 percentage of your emails, it is approximately correct. That's more important. Okay, approximation. The mistake bound framework, on the other hand, looks on how the algorithm learns over time. It evaluates how many mistakes an algorithm makes before it converges on the correct model. So, this tells us how efficient a learning process can be. So, both frameworks guide AI researchers in designing smarter and faster learning algorithms. Next, we will discuss about neural and evolutionary computation. These are two biologically inspired learning algorithms. So, neural computation is inspired by how human brain works. So, artificial neural networks, otherwise ANN, simulate interconnected neurons that processes data and learns the patterns, especially in fields like image recognition, speech processing, and NLP or natural language understanding. Neural computation forms the backbone of deep learning, powering technologies like voice assistants and autonomous vehicles. Next, we will talk about evolutionary computation. It draws the inspiration from the Darwin's theory of natural selection. Here, genetic algorithm evolve solutions over time, selecting the fittest candidates through mutation and crossover operations. So these algorithms are particularly effective in solving multidimensional or complex problems. So it tries to optimize it. For example, like network design or financial modeling problems. So together, neural and evolutionary computational techniques push the boundaries of how machine can adapt and learn. Next, we will talk about intelligent agents and multi-agent systems. Otherwise, it's called as MAS. So, an intelligent agent is a software program designed to assist users or perform tasks autonomously. So, it is goal directed. We know multiple agents are there. So, it's goal directed, flexible, and reactive. So, it first observes the environment and then process the information and achieve and acts to achieve the specific objectives. So, when multiple agents work together, sharing information and collaborating to achieve complex goals, then it is called as multi-agent systems. So, this enables timely decision making in situations that would be too large or complex. Instead of a single agent handling all these things, when multiple agent does so, it can take good decisions or optimal decisions. Now we will take a simple example. So imagine a student studying a web design course. Okay, they use a search engine to find learning material for the subject. So the search engine here is an intelligent agent. What it tries to do? It observes which sites the student visits and how they interact with the content. Over time, it learns their preferences Maybe the students like illustrated tutorials better than plain text. The agent then adjusts its behavior, recommending more image rich resources in future searches. So, this feedback loop of observation, learning, and adaptation is how the intelligent agent works. Now, we will talk about why multi-agent system is needed. So, capacity of a single agent is limited or restricted in terms of knowledge and resources. So, each agent perceives only a part of the environment and not complete. So, for complex problems like, for example, if you take the traffic management system, disaster recovery, or stock trading, combination of multiple agents with different perspectives produce better outcomes. Okay. So, in a multi-agent system, each agent have their own capability and computation efficiency so that the overall performance is improved. Next, we will discuss about multi-perspective integrated intelligence. It's called as MPI. So, this takes the idea more further. So, when facing a problem or any problem to solve, each and every individual can have his own perspective. Okay. So, some information might be present in one perspective while missing in another. So, which could be effective in decision making. So, so by merging the insights from multiple perspectives, okay, we have to exploit the knowledge and explore from different agents from multiple perspectives to build an intelligent system so that more accurate and robust solutions are made. So, MPI is about integrating different viewpoints into a single, more intelligent framework. Now, let us take an example of MPI in a real world situation. Suppose, imagine you are applying for a job at a renowned company. Okay, you talk to multiple employees, one from a management, one from a engineering, one from human resource. So you get the feedback, you get different views. Each employee share their own perspective. Okay. Now, based on all this information you have gathered, you decide whether to take up the job or not. Okay. You might also try to consult a friend who previously worked there. So each piece of feedback represents a different perspective. So by combining all these insights, you make a more informed decision whether to join the company or not. So this is exactly how the MPI system functions, collecting and integrating multi-perspective data for optimal decision making. So to summarize, knowledge discovery and data mining is a process of extracting meaningful information from unknown patterns from data. So it's widely used in business intelligence for data driven decision making. So when we talk about machine learning, it's a field of algorithms that improves the performance with experience. So it enables a system to learn and improve the performance through the experience. Then we discussed about computational learning theory. It's also called as COLT. So these are the formal, it provides the formal frameworks like PAC and mistake bound to evaluate learning efficiency and limit. So, fourth, we talked about neural and evolutionary computation. So, brain inspired neural networks and evolution based algorithms are used to solve complex pattern recognition and optimization problem. Fifth is about intelligent agents and multi agent systems. So, intelligent agents are goal directed software programs that work together in a multi agent system to solve a complex problem, or so that every agent's capacity is utilized properly. Last one is multi perspective integrated intelligence. So, it is a framework that combines knowledge from multiple perspectives to build accurate intelligence systems for decision making. So, the references are from Stuart Russell and Peter Novick, and then Parag Kulkarni. So, both are excellent resources to learn the fundamentals. Thank you.